So today we discuss the SR latch with NOR gate. So this is the diagram SR latch with NOR gate. There are two NOR gate and the output of S is Q bar and output of R is Q. For understanding the truth table TT of SR latch, we have to first understand the NOR gate. From this NOR gate we know that if any one is 1, any input is 1, then output is 0. This is the basic logic. 0 1 0 1 0 0 1 1 0. So any input is 1, any input is 0, then any input is 1, then output is 0. So first we take this, that is S equal to 1, R equal to 0. So S equal to 1 and R equal to 0, we take this. Then what happened? What is the logic? Anyone is 1, then output is 0. So this will be 0 and this 0 is come here. This is the output. Then 0 0 means 1. So this equal to 1. That is when 1 0, then Q equal to 1 and Q0 equal to 0. This is the first. Next. Next is 0 1. That is S is equal to 0 and R equal to 1. When R equal to 1, then Q equal to 0. We know that anyone is 1, then output is 0. So Q is 0. This 0 is moves here. That is 0 0 means 1. So this is 1. So what happened? Q equal to 0 and Q bar equal to 1. No problem. Now if both are 1, then what happens? S equal to 1 and R equal to 1. Now anyone is 1, then output is 0. Anyone is 1, then output is 0. So this will be 0 and this will be 0. Anyone is 1, then output is 0. So Q equal to 0 and Q bar equal to 0, it is not possible. So this is the invalid or not use or not use. We cannot use, not use, invalid state. And the last is the if both are 0, then what will happen? This is 0 and this is 0. What happened? If anyone is 0, then what happened? If we move to Q bar, then what happened? Q bar equal to S. S means 0 plus this Q. This Q. Then what will happen? And this is the bar. And then what will happen? No. What happened? Then 0 plus Q bar, that is 0 bar dot Q bar. 0 bar means 1 into Q bar. That is 1 into Q bar means Q bar. So what happened? Q bar equal to Q bar. And similarly for Q, where Q equal to R, R is 0 and another is Q bar. So what will happen? Then bar as it is NOR gate, so 0 bar plus Q bar. That is, this is not plus, this is into De Morgan's rule. This is 1 and this is Q. So this is Q. So Q equal to Q. So this is the memory state. This is the memory state. Q equal to Q and Q bar equal to Q. So this is the SR latch with NOR gate. Similarly, we can get the SR latch with NAND gate. SR latch with NAND gate. The diagram, we need two NAND. So this is S and this is R, and this is the output and this is the output. Here is the Q and here is the Q bar, the opposite, and from this move here, and from this another move here, another input. So this is the SR latch with NAND gate. Now, before starting the truth table, TT of SR latch with help of NAND gate, first we have to know what is the, so no, there is a bubble. There is a bubble. Why? It is the NAND gate. This is the AND gate and this is the, when put the bubble, then this is the NAND gate. Now, what will happen? In case of NAND gate, A, B and output 0 0 0 1 1 0 1 1. You know that when it is 1 1, then it is 1. So here is the 0, all are 1. So what is the meaning? If anyone is 0, output is 1. You check that. So this is the basic logic. Anyone is 0, output is 1. Now we put here again S, R and this is Q and Q bar. So 0 0 0 1 1 0 1 1. So anyone is 0, first we take this. That is S equal to 0 and R equal to 1. S equal to 0, R equal to 1. Anyone is 0, then output is 1. So this output equal to 1. And this 1 is moves here. 1 1 equal to 0. So what happened? Q equal to 1 and Q bar equal to 0. Next, this opposite. S equal to 1 and R equal to 0. Anyone is 0, then output is 1. So here is the 1, this one move here, 1 1 means 0. So Q equal to 0 and Q bar equal to 1. But if both are 1, what will happen here? Check. And both are 1. You check that. Both are 1. Then what will happen? For Q, we need for Q 1 into dot Q bar. Q bar anything, this bar. There is De Morgan's law, 1's complement plus Q bar bar. Q bar bar. That is what happened? This is equal to 0 plus Q bar Q, that is equal to Q. That is Q equal to Q. Q equal to Q. And similarly for Q bar this equal to 1 dot and coming from Q. So this is bar. So 1 bar plus Q bar. 1 bar plus q bar, that is 0 plus q, that is q bar, that is q equal to q bar. So here in this case it is the memory, it is the memory state, that is as previous, store the memory. And in case of 0 0, this is the last condition. In case of 0 0, what will happen? To check that both are 0, both are 0, and this is the 0. When 0 0, what will happen? And here we check that in case of q, this is 0 dot q bar, bar 0 dot q bar. And what will happen? So 0 bar plus q bar, that is 1 plus q, that is equal to 1. 1 plus q equal to 1. And similarly q bar equal to, here is the 0 dot q bar. So 1 bar, not 1 bar, this is 0 plus q bar. Then what will happen? So this is 1 plus q bar. This is also 1. So both are 1. Both are 1. It is not possible. Q equal to 1, q bar equal to 1. So it is not possible. So it is invalid. Invalid or not used. So this is the SR latch with NAND gate. Previously we discussed the SR latch with NOR gate. So in our next discussion we will discuss the SR not latch, this is flip flop. Thank you.